Now it's your question number 20. Here also it is almost similar to question number 19. See, at first you have to remove this radical sign. Your first attempt, what to substitute so that this becomes free from the radical sign. If you take, let root x equal to sine theta, root x equal to sine theta, or you can say x equals to sine square theta, as you wish. So either you can say root x equals to sine theta, that is x equals to sine square theta. Then see, dx is your 2 sine theta cos theta d theta. Then put the values in I. So then this becomes I reduces integration under root over root x is sine theta. Here what you will get? 1 minus sine theta divided by 1 plus root x. Root x is your sine theta. So 1 plus sine theta. dx is your 2 sine theta cos theta d theta. 2 sine theta cos theta d theta. This gives you I equals to integration of, do one thing, rationalization, 1 plus sine theta, you take 1 minus sine theta and multiply numerator as well as denominator. And in the numerator you see 1 minus sine theta you will get, divided by, and under root over, here it will be 1 minus sine square theta into 2 sine theta cos theta d theta as it is. This gives you I equals to integration of, see, 1 minus sine theta as it is by under root over 1 minus sine square theta is what? Root over cos square theta. So what will come out? Only cos theta will be here into 2 sine theta cos theta d theta. Now this cos theta cancelled out. Then I equal to integration of, just multiply this, 2 sine theta minus 2 sine square theta minus 2 sine square theta and d theta. This you will get. Now first part already obtained twice of integration sine theta d theta minus integration of 2 sine square theta d theta equals to integration of sine theta is what? Minus cos theta. So minus twice of cos theta. Now what about 2 sine square theta? As you know that cos of twice theta is equals to 1 minus 2 sine square theta. So from here you will get what? 2 sine square theta is equals to 1 minus cos of twice theta. So let us write minus integration of 1 minus cos of twice theta. This is using trigonometric identity. The formula 2 sine square theta is equal to 1 minus cos of twice theta. That formula we have used here. Then this equal to minus 2 cos of theta and minus integration of, so let me write directly theta. Term-wise integration of this minus it will be plus integration of cos twice theta. So integration of cos twice theta is how much? Sin twice theta by 2. So sin twice theta by 2. Now you can give the constant of integration plus c. Now just what part is left, you have to give back the values in terms of x. So let us do this. Sin square theta is your x. So cos theta is your under root over 1 minus cos square theta. Cos theta is your under root over 1 minus sine square theta. So that is nothing but minus 2 under root over cos theta is your 1 minus x, 1 minus x, because sine theta is your root x. Therefore cos theta is root over 1 minus sine square theta. That means only x. Minus theta. Theta value from here you can get. Theta is your sine inverse root x. So here it is sine inverse root x. This is theta. I have replaced as sine inverse root x. This one you see plus 1 by 2 sine of twice theta. So sine of twice theta you can write 2 sine theta cos theta plus c. Let me write here. Then here you will get what? This implies finally I equals to, almost you have obtained the value of I, minus, see here, I equals to minus twice of root over 1 minus x square. Then minus sine inverse what? Root x. 2 cancelled out, plus sine theta. Sine theta is directly root x. Sine theta is your root x. And cos theta, under root over 1 minus sine square theta means 1 minus x. So under root over 1 minus x plus c. So finally you can write I equals to minus 2 under root over 1 minus x square minus, this is what? Sine inverse root x. So sine inverse root x. And this you can multiply root x into root over 1 minus x. That's plus under root over x minus x square plus c. This is your answer. So this was the solution of question number 20. Now let us take question number 21. Some mistake I have done here. Let me see where is the mistake. Wait. I am sorry. Here it is minus 2 root over 1 minus x. So minus 2 times root over 1. It is not x square 1 minus x. It is minus 2 root over 1 minus x. That is it. And here it is root x into OK. Textbook answer what way they have given. So let me show that one also. I equals to, in your textbook answer, it is root over 1 minus x is common. You can take root over 1 minus x common. This root over 1 minus x. Then within bracket what is left? Here it is root x and minus 2. Minus 2. It means if we take, or you can take minus, if you take minus root over 1 minus x common, then here it is 2 minus root x. 2 minus root x. From these two, from here and from here. From these two terms, root over 1 minus x is common. And then minus sine inverse of root x plus c. In your NCERT textbook, answer is given, I think, in this form. And if you want, you can keep the answer that way also. That is also correct. Thank you. Now take the question number 19. Sorry, 21. So question number 21. Oh, let us see in question number 21 what is asked. Question number 21. Here I equals to, you see, 2 plus sine of 2x in the numerator, 2 plus sine of 2x divided by 1 plus cos of 2x, 1 plus cos of 2x e to the power x dx. This is your question number 21. It's easy one. Already you know that special integration, that property known to us, integration of e to the power x fx plus f dash x. This becomes what? E to the power x f of x plus c. This type of integral known to us. And this function to be expressed in this form, so that we can write the integral. So let us try. I equals to integration of 2 plus sine of 2x, you can write 2 sine x cos x, 2 sine x cos x divided by 1 plus cos of twice theta. 1 plus cos of twice theta, the formula should be known to us, that is your 2 cos square theta. So here it will be twice of cos square x dx, implies I equals to integration of 2 by 2 cos square x, let me write directly, it is your sec square x, plus 2 sin x cos x divided by 2 cos square x, that's nothing but 10x as a whole. Sorry, here e to the power x is there, e to the power x dx. This e to the power x I forgot. E to the power x, it was missed here, e to the power x is here. So e to the power x dx. Now see, it is nothing but integration of 10x plus ddx of 10x, ddx of, or you can say derivative of 10x. That 10x I have written here, and here in place of sec square x I have written derivative of 10x and e to the power x dx. Now it is in which format? In this format, and value of this is what? E to the power x fx. So directly you can write I equals to e to the power x f of x. In this case fx means 10x. So it is your 10 of x plus c. This is your answer. Now let us see question number 22. Now this is your question number 22. I think this type of problems already we have solved. It is directly partial fraction method. So using partial fraction we can find out the integral. So see, take the integrand x squared plus x plus 1 divided by x plus 1 whole square into x plus 2 equal to. So first of all you check whether it's a proper rational function or not. Yes, it's a proper rational function because degree is 3 here and degree is 2 here. So what to do? How to assume? And you have to assume a by x plus 1 plus b over x plus 1 whole square plus c over x plus 2. After that, by this you have to multiply each term. It is your x square plus x plus 1 equals to a times x plus 1 x plus 2 plus b times x plus 2 plus c times x plus 1 whole square. You can give it number 1. Your aim is to find out the values of ABC. ABC are any numbers, and if we can obtain the numbers ABC, that means this is expressed in terms of partial fraction. Now the question is how to obtain ABC. For that, let us do one thing. If we take x equals to negative 1, for x equals to negative 1, 1 implies. Then if you give negative 1, this term is 0, this is also 0. And in left hand side what you will get? Negative 1, that is your 1 plus 1. So let me directly, it will be 3. It will be 3. Equal to, it is vanished. This is vanished. 2 minus 1, 1. It is your b. It means b we have obtained as 3. Then for x equal to, say negative 2, x negative 2, then 1 implies. If you take negative 2, square it, 4 minus 2, sorry. If we take x equals to negative 1, then it is your 1 minus 1, 0. It is 1. It is 1. B is 1, not 3. Now, if we take x equals to negative 2, then square it 4, minus 2, then plus 1. Plus 1. Equals to here, negative 2, it is 0. First term is 0. And second term is 0. So, minus 2 plus 1 minus 1, that is your C, plus C. Then value of C you obtained as C how much? 4 minus 2, 2, 3. C is your 3. Now we have to find out value of A. For this, just you take for x equals to 0 suppose. If we take x equals to 0, then 1 implies. 0, 0, left hand side 1 equal to 0, 0. So 1 into 2, 2, twice A. Twice A. It is 0, then it is simply twice of B. And plus C. But already B and C you obtained. B is your 1, C is your 3. So if you substitute this, then 1 equal to twice A as it is, and twice B plus C. B is your 1, twice B is your 2, plus C, that is twice B plus C will be 5 then. So it is your plus 5. Equals to twice A equal to negative 4, and A value is your negative 2. So finally, I becomes what? Therefore, I equal to, let us put the value, integration of this much, that is your I, integration of this, A is your negative 2, so negative 2, integration of 1 by x plus 1 dx, plus B over x plus 1 whole square. So B is your 1, so plus integration of 1 by x plus 1 whole square, you can write x plus 1 whole to the power negative 2 dx. B is your 1, so directly we have written B is your 1, so it will be 1 by x plus 1 whole square, means x plus 1 whole to the power minus 2 you can give. And C by x plus 2, C how much? C is your 3, so plus 3 times integration of 1 by x plus 2 dx equal to I equals to, see, this implies I equals to minus twice log of modulus x plus 1, and integration of this is what? This must x plus 1 whole to the power minus 2 integration x plus 1 whole to the power minus 2 plus 1 by minus 2 plus 1. So here minus sign will come, and it will your x plus 1 whole to the power minus 1 plus 3 times log of modulus x plus 2 plus c. Already you obtained the answer. Your I equals to, just you write, this is positive term, let me write here, 3 log of modulus x plus 2 minus twice log of modulus x plus 1, and this is minus 1 by simple x plus 1 plus constant of integration c. This is your answer. This was the solution of 22. Now let us see question number 23. Now question number 23. Here also substitution, similar types of substitution you have to do. Tan inverse root over 1 minus x by 1 plus x. See, first of all, your aim is to remove this radical sign, and for that you have to substitute, let, if you take x equals to cos theta, remember x equals to cos theta, then dx is your as usual minus sin theta d theta, then I is your what? I equals to integration of tan inverse under root over 1 minus cos theta by 1 plus cos theta, and dx is your minus sin theta d theta. This much you will get, minus sin theta d theta. This gives you I equals to integration of tan inverse. See, 1 minus cos of twice theta is your 2 sin square theta, and 1 plus cos of twice theta is your 2 cos square theta. This formula you have to use here, and if you use that formula, it is what you think it is 1 minus cos of twice theta, then it is just 2 sin square theta by 2. I mean to say, we know that 1 minus cos of twice x, if I say, that is your 2 sin square x, and if you take twice x means theta, then x is your what? Theta by 2 divided by 2 cos square theta by 2 into minus of sin theta d theta. Then this implies I equals to integration of, let me do one thing, this negative sign let me write here. Then 2 cancelled out, sin square by cos square tan square, root over cancelled out, then only tan inverse tan of theta by 2 you will get, and here what is left? Sin theta d theta. This implies I equals to minus integration of tan inverse an identity function theta by 2 into sin theta d theta. So almost you have done. That is finally negative half constant outside the integral sign, theta times sin theta d theta. Remember, here it is algebraic function, it is trigonometric function. So you have to go for by parts, taking I as the first, theta as first function, this as a second function. So that's why I equals to minus half, it is common as a whole. We are going to use by parts here. By parts will first function as it is, integration of second function, integration of sin theta, it is your minus cos theta, that is known to us. Then by parts rule minus integration of derivative of first function, that is 1, integration of second function, it will be same, minus cos theta. So minus cos theta d theta, this we will get, equal to, then it is half of theta cos theta, this is minus minus positive sign, and here you see, do one thing, minus of this minus plus half of, and minus, this is minus sign, plus again here it is negative sign, ultimately it is minus half of integration of cos theta. Integration of cos theta is your sin theta, so simply write sin theta plus c constant of integration. So finally I have to replace the value of theta in terms of x. So theta is your what? Cos inverse x. Cos theta is what? X. Cos theta is your x. So half of, let me write value of cos theta at first x. And theta is your cos inverse x. So I can write cos inverse x here. Minus half of sin theta. Cos theta is x. So sin theta is your root over 1 minus x square. So under root over 1 minus cos square theta, that is your x square plus c. So this is your final answer. You can do one thing also here, half you can take common, x cos inverse x minus under root over 1 minus x square plus c. This is your final answer. Now let us take the question number 24. So in miscellaneous exercise, 24 number of questions are given, indefinite integral and rest of the definite integral. So with the solution of question number 24, we will finish all the miscellaneous exercise of your indefinite integral related questions. Let us see question number 24 now. Now question number 24, this is the last question of indefinite part from your miscellaneous exercise. So here some special arrangement you have to do at first. See, root over x square plus 1 divided by x to the power 4, this by this, into log of x square plus 1. This is nothing but log of, directly you can write x square plus 1 by x square using the property of logarithm. How we can write this? This is log of minus 2 log of x means log of x square. Then log a minus log b equal to log of a minus b. That's why you can write log of x square plus 1 divided by x square with respect to x, that is dx. After that, integration of under root over x square plus 1, let me write x here. Let me write, sorry, x square here, into. Now, under root over I have written x square, and if this x square, if you take out of the radical sign, it is what? 1 by x, it will, only x will come out. That means 1 by x square, this is under root over x square plus 1 by x square. So if this x square taken out, this is your x, as a x it will come out. It means log of x square plus 1 by x square as it is into 1 by x cube I have to give here. Then from here x come out, x into x cube, x to the power 4. This is the most important steps of this problem. I repeat, x to the power 4, x to the power 4 means what? X into x cube, that x cube is here, 1 by x cube. And where is the another x? This is under root over. And if you take x inside the root over, it will be x square. Then only if you take out, then you will get back as a x. Okay, it's a simple procedure, just we have arranged it like this. Now you see, integration of under root over x square by x, this is 1 plus 1 by x square, into log of, divide term wise, 1 plus 1 by x square, into, it is dx, 1 by x cube dx. Now substitution, let 1 plus 1 by x square equal to t. Then on differentiation, what you will get? Minus 2 by x cube dx equal to dt. So from here, you will get 1 by x cube dx equal to minus half of dt. This minus 2 taken to the right side. So this is your minus half of dt, or you can say minus dt by 2. So 1 by x cube dx to 1 by x cube dx minus half of dt we obtain. Now put the values in I. This implies I equals to, see, this is integration of root over 1 plus x square, and 1 plus 1 by x square is what? T. So this is root over t. This is nothing but t to the power half, because root over t means in exponential form it is t to the power half. That's why directly you can write t to the power half, into log of what? 1 plus 1 by x square. So into log of simply t, because 1 plus 1 by x square we assume as t, and 1 by x cube dx is minus half of dt. Let me write minus half here, and simply you write dt here. Now it is what function? It is your algebraic function, it is logarithmic function. Then you have to apply bypass rule, and if you apply bypass rule, minus half, give third brackets here, first function as it is t to the power half, algebraic, it is algebraic function, it is your logarithmic function. So which function should be taken as the first function? The trick is I let I means inverse, L means logarithm, A means algebraic. So in that sequence, L is coming, logarithm come at first. So it is your first function, and this is your second function. So first function as it is, integration of second function. So that is your t to the power half plus 1. Let me write directly half plus 1 is what? 3 by 2. 3 by 2 divided by 3 by 2 minus integration derivative of first function, that is your 1 by t, and into integration of this much will come t to the power 3 by 2 divided by 3 by 2, and it is your dt. This by parcel we have used. See these steps clear or not? I repeat, by parcel we are going to use, for that logarithm should be taken as first function. This is your second function. And as per by parcel, first function as it is, integration of second function minus derivative of first function 1 by t, integration of second function, so integration of this. Now, so after that, using by parcel, that is first function as it is, then derivative of second function minus derivative of first function and integration of second function, that is integration of t to the power half, so 3 by 2 by this. Now finally it is your minus half, and here it is within brackets log of t into, it is your what, 2 by 3 and t to the power 3 by 2. Now minus, this is 3 by 2, let me write 2 by 3 here, integration of t to the power 3 by 2 minus 1 dt. This much you will get. Then minus half, and this is 2 by 3, that is nothing but minus 1/3 of log t into t to the power 3 by 2. Then minus, and if you multiply this, then it is your plus, here it is your plus sign will come, this minus and minus plus. Okay, then half into 2 by 3, that will be your 1 by 3, and integration of t to the power 3 by 2 minus 1 is what, 1 by 2 dt. Almost we have done. I repeat, the constant of integration at last we will add. So here it is minus 1/3, let me write this t to the power 3 by 2 log of t plus 1 by 3 into t to the power half means t to the power half plus 1, that will be 3 by 2 divided by 3 by 2. Now we can give plus c constant of integration. So finally you see I equals to your minus 1/3 into t to the power 3 by 2. And what was your t? T assumed as what? Check it. So what was your t? T was your 1 plus 1 by x square. So let me substitute this, 1 plus 1 by x square whole to the power 3 by 2. Now it is your 1 by 3 into by 3 by 2, that is 2 by 3, that is nothing but plus 2 by 9. 2 by 9. T to the power 3 by 2. So t is your 1 plus 1 by x square whole to the power 3 by 2 plus c. This much you will get after simplification. Then finally here t to the power 3 by 2, so 3 by 2 log of t is left, log of t is left, let me write it properly. So implies I equals to minus 1/3, t means 1 plus 1 by x square whole to the power 3 by 2 into this term was missing log of t means what? 1 plus 1 by x square. We missed it earlier. So now 1 plus 1 by x square. Remember, rest of the part as it is 1/3, that is 2 by 3, that will be your 2 by 9, and t means 1 plus 1 by x square whole to the power 3 by 2 plus c. So almost you have obtained the answer. Here also you can give the answer, but if you want, you can take common. What is common here? 1 plus 1 by x square whole to the power 3 by 2. I can take common minus 1/3 of 1 plus 1 by x square whole to the power 3 by 2 common. So within bracket minus 1/3 into 1 plus 1 by x square 3 by 2 common. So what is left here? Log of 1 plus 1 by x square. This part is left. And here just plus, not plus, here it will be minus sign because you have taken minus 1/3 1 plus 1 by x square whole to the power 3 by 2 common. Then you have to give here what? 1 by 3 here. Then it is minus 2 by 3. Only 2 by 3 is left. This. And constant of integration c. This is your answer. And if you multiply this, you will get minus 1 by 3 into minus 2 by 3. That is your plus 2 by 9. This was okay, correct. So in your NCERT textbook, answer is given in this form. Thank you. So it means we have solved all the indefinite integration problems from your miscellaneous exercise 7. Thank you.